Hi everyone. We're going to be working with the TS10 today. That's a Tesla switching device, and right now we've got it hooked up just the way it was last video that everybody has seen, and we're going to increase the trigger coil. We got 1246 on the battery, and we're only charging one battery right now just because it's simpler to work with for this test. I've got it energized, it's running, and we're putting out 400 milliamps through the unit right now, and the frequency is 7.38 K, and we're running 6.36 volts on the charge battery, and the first one I showed you was 12.6 is on the battery bank, because we're charging below what normally you do. But with the Tesla switch, you go from 12 volts to 6, or you go 24 to 12, and you get much better charging at that. And so that's what we're doing. But what we're going to do today is we're going to see what this thing actually puts out. I've never had an amp meter on the front end. I just know I can charge it really good in about 20 hours. So this is what we're going to do today. I put my big potentiometer on it right here. We're going to crank this thing up and see what happens. I've never done this before, so I don't know what we're going to get. Right now it's set at 200 ohms, and we'll just start cranking the pot up. And as you crank the pot up, and I say up, meaning going to 0, or in this case 3 ohms is as small as this goes down to, you can see the milliamps start going up, and the frequency comes down, and the battery voltage should start going up momentarily. Alright, we're just about 100 ohms right now. So you increase it from 200 to 100, or decrease it, however you want to say it. We went from 40 to 65 on the milliamps, and we're down to 5.09 on the frequency, on the hertz. And this is where I wished I had a little bit more range on this pot to make more intricate movements, but it's going to start percolating real quick. And we're down to 3.3 for hertz, and the charge voltage went up to 675, 6, and 7, and it's climbing quick, and the amperage is 1.13. And we're going to crank it a little bit more. We're getting down to probably 10 ohms, maybe a little less. And frequency's down to 2.0 or thereabouts. Charging voltage went up to 6.8 volts, and the amperage is 1.8. And when I had this running for the most part of the fall, charging batteries, I had a 8 ohm resistor on it, and don't know, we're pretty close to the end, so we're not far away. And it's kicking about 2.5 amps, 1.6 on the hertz, and usually ran it at 1.5, and the battery is already up to 7 volts. So it's kicking pretty hard. Okay, there's 2.86 and 1.4 for the hertz, and the battery's up to 704. And there's all the way down. That's 3 ohms. And we're kicking 285 for the amperage, and 1.43 for the hertz, and 707, 708 for the battery. Now we're going to do something that we've done back at Christmas. This is a new part of what you can do, and I'm going to shut this thing off and get back with you as soon as I make the modification. Okay, let me explain what we've done. We have done, by adding, what we've done is add a diode right here. That's a 5408 3 amp diode to the trigger line. This is trigger coming in this side, goes across the capacitor and out through the diode, and it has to be there. The capacitor has to be across the 2 lines for the resistance, which this is really kind of unique. I've never seen this thing actually work like this with this big a unit. I mean, it's cruising. The battery voltage, I got it cranked up or down, however you want to say it, to 200 ohms. We're now running at 14 hertz. I've never seen it go that high. And the battery voltage is still charging, slow but sure. 6.69, 6.7 is what it's flashing at 180 milliamps. It'd be interesting to see how much this will charge one of these big batteries, but that's not what we're here for. I want to see what it does when we kick this trigger. So that's what we're going to do. Watch the meters. We're going to take it down and go to 3 ohms and see where it comes out at. Usually the resistance has to go lower, will go lower to come up with the same numbers that we used to. And well, we're all the way down to 0, and it's 286, and one capacitor doesn't look like it's going to do a whole lot. The voltage is a little higher on the battery, 7.11. The the amps are 2.8384. The battery's still charging. So I'll tell you what we're going to do. We're going to put another capacitor on it and kick it a little harder. Be right back with you. Okay. Here we are back again. We now have 2 of these 10 joule capacitors, 250 volt AC, and we have still only 170 milliamps. The frequency didn't change a whole lot more. It's still at 14.5, and the charge battery is now at 6.71. So just adding that didn't really do a whole lot to it. So let's crank it up again and see what she does. There's about 100 ohms coming down. Four. Well, input amperage is about the same, 2.83, 1.45 for the hertz, and the charge battery is saying 714. So two capacitors is not changing as much as I thought it would. But we are running out of potentiometer. I need to get a lower one than 3 ohms. This is different for me. I guess I'm going to have to put an 8 ohm that I got down here across it so I can drop that substantially so we can see what this thing will really charge to. I guess I need to get down into the 0.5 ohm range, but we're going to put on another capacitor. So I'll be right back. Okay, we're back. We now have 3 of these yellow 10 joule capacitors on it. This is at 200 ohms on the pot, and we're running 1.7, 1.6, 160, 170 milliamps on the input. Still the frequency is 14.6, and the charge voltage and the battery, it seems to be climbing again on lowest input that I can give it. So once again, let's crank it up and see what happens. Well, now I am almost to the bottom of the pot, and I still haven't hit there. We just got 2 ohms, and I can't be more than 4 ohms. I'm at 2 amps, and I can't be more than 4 ohms for maximum. So there's maximum, which is 3 ohms. And frequency is a little higher. And the amperage is a little lower. And the voltage is a little higher. Gee, I wonder what's going on here. I guess I just have to get a lower resistor. But before we do that, we're going to go on. I got, I think, 1 or 2 more, but I only have room for 1 more on my string here. I don't know, I might be able to squeeze 2 more on, but I'll try it. Be back with you in a minute. Okay, we're back. We now have 4 of the yellow capacitors online, and our battery voltage on the bank is, of course, we're running on the big bank, or one of them. That's 1244. So we come down 1/100 of a volt. I don't know if you can see that in the camera. Yeah, I guess you can. So, we're not taking any battery juice out of the bank. So let's see how things are going. We got 1.6 amp draw. So the more capacitors we put on, the less amp draw that we're getting, and this is at 200 ohms. The higher the frequency is getting still. I think we was at 14.5 at some point. I'd have to go back and look at the film. But anyway, the battery charge is 6.76. So let's crank it up and see what this one does. I don't expect to see much more till I lower the resistance below 3 ohms. I'm down almost to the bottom, and I haven't even hit 1 amp yet. And we're about just about 3K, and now we're hitting 2 amps, 1.9 hertz. Okay, that's wide open. That's 3 ohms. Guess I'm going to have to see if I have I think I have a 2 ohm solid resistor that I can put on here. See if we can kick it a little harder. I am noticing that the more capacitance you put on it, the lower the frequency has to be in order to start it oscillating. I had to run it wide open this last time or not wide open, almost closed, meaning down in the probably 20 ohm range for it to start. So with you people out there that have a problem of starting your solid state units, I would suggest putting a lower ohmage on it to see it start. But anyway, I'm going to go see if I can find a lower ohm and come back and see if I got a 2 ohm to put on this, and then we'll do some more. But the frequency is 1.5, so that didn't change. The amperage is down 2.72, 2.71, and it's 7.27 for the charge voltage. And if you double 7.5 will be 15 volts in 12 volts. So at 15 volts, this should be almost charged. And that's the way you figure it when you charge only a 6-volt range. I'll be back. Let me go check my resistance box and see what I have. Well, we're back. All I could find was the original 8 that I had in here, and I have a 1.2 ohm, and that's what we're going to put in next. I could try cross with the, I have also a 10. That'll bring it down to 4 ohms, so we can see what that looks like too, but I'll do them one at a time. Get it started and be right back, although it should start now. Pretty simple. And that's the 8 ohm is what I used to have on it, and it draws an amp and a little over an amp and a half, frequency of 2.5. So that's what I used to run at 1.5 frequency. So with the same ohmage that I used to have on here, the frequency has gone higher. So yes, I will have to drop my ohms down in order to get what I used to do on here for battery charging. So I'll be right back, change the put the resistor on. Maybe I can just put it across here. Let me try that first, see if I can hook this thing up. I hate doing stuff like this. Oh yeah. So 2.6, that's not going to be quite 3 ohms. I think I'll run it out on the computer. It was 4.4 or something like that. Use our parallel ohms chart, thanks to HK, and figure it out. But there, I think it's 4.4 ohms, and we're not getting the same thing that we got when we left with the 3 ohms, so we're going to put the 1.2 ohms across it and see what that does. Ooh, stand back. I'll be back. Okay, here we go with 1.2. We might have smoke. So let's see what happens. Oh, it did come down a little bit. That's 1.2 ohms. And that's about 150. Daggone it, I'm going to have to go below 1.2 ohms. Well, let's see what do we got here. That's the 10 ohms. Okay, that's the 8 ohms. I'm going to have to go to the store and buy something down in the single point something. I always knew I'd get to this point in pulse solid state where I'd have to have less than an ohm to operate a machine. That's kind of bizarre. But the battery is definitely percolating. I can hear it over there bubbling away. But that's enough for now. That's called the cap pulsar, or not the cap pulsar, the CAP-DIODE modification. And you get to see it now on some, I'll call it big equipment. You can charge 1 battery, 2 batteries, 3 batteries. You can charge whatever you want on this as long as you can get your resistance down low enough. And that's the next key thing. I got to go buy half-ohm resistor, and maybe a couple of them to get down to where this thing will operate like it's supposed to. So, there you go. Hope you had fun. The battery's still boiling away. See you later. Well, one more addition. I just took the amp meter out of line and hooked it back up. Little did I know that amp meter was really holding back a lot. Watch both the other two meters that we got. That's 0.7 K on the meter for frequency, and the charge meter is up 20 points higher than it was. So, and the battery is boiling really good. So that's telling me that that amp meter was holding back about 3/4 of an amp or whatever, I don't know, but 1.2 1.2 ohms is definitely kicking this thing with the capacitor in line, capacitors. And yeah, that battery, I've never seen it be so high. I might be in trouble here. That's something else. And that's with the 10 transistor. And all I can say is it works. Works very well. I'll have to do another one of these with 2 batteries online, because I think this is too easy for it. See you later. Bye.